Hello everyone, today we will see how to calibrate Arc SWAT model using SUFI tool. Welcome to my video tutorial. This is actually tutorial 3. For similar and related videos, click the subscribe button shown below on my YouTube channel. Therefore, I will start by creating new project wizard. Therefore, before that, I have to open this Arc SWAT program. Therefore, I will go by clicking start, then search SWAT-Cup. Here this is SWAT-Cup. Open it. Then the second step is just by clicking the start button. I will go to new, then next, and I will have to choose text in out location. Then I will go for next, then I will choose this SWAT version as well as processor architecture. Then I will select project type as SUFI 2 because SWAT-Cup generally have 5 project types. Among this, I will select SUFI 2. This is SWAT-Cup in the interface. Therefore, I will start by clicking this start button. Click here start, then new, then next here. I will select text in out location. Here there is a browser. Click here browse. I will go to desktop. This is tutorial 3. This is my SWAT model. Therefore, I will refer this 1987. This is SWAT model. Then select scenario. Then warm up period 8 here. I will select this folder. In this folder there is text in out. In this pink folder, therefore I have to choose this text in out folder. Then open it. Next, select SWAT version. If your SWAT model is 2009, I will select this one. You should have to select 2009, but for me I have SWAT versions of 2012. Therefore I have to select 2012. And processor architecture. If your computer version is 32-bit operating system, you have to select 32-bit operating system. But for me, I have this PC is 64-bit operating system. Therefore, I have to select as this 64-bit. Then next, I have to choose project type among these 5 project types, SUFI 2. Then next, I have to give a name for my project. Therefore, this is, let's say, tutorial 3. I have to select project location in which all tasks should be saved. Therefore, this is a folder in which all the work should be saved. Therefore, here browse. Then I will go to desktop, and here I will create here new folder. It's possible. SWAT-Cup. Okay. I have to select this one. Then press here OK. Then finish. New project wizard is created in such a way, and here SWAT model is copied from text in out folder to SWAT-Cup in such a way. It may take a little bit of time. Therefore, it's busy. The next step is just the available stream flow data range from 1988 to 2005, and sensitivity analysis performed by the available flow data year. This is sensitivity year. You can take this one from 1988 to 2005. After sensitive parameters are identified, calibration period will be reduced to 1988 to 1999. Therefore, after new project wizard is created, we'll go for editing calibration inputs. Under calibration inputs there are parameters info and SUFI to SWAT editor. Therefore I have to edit this calibration input. I will go to, this is calibration input, this plus sign, click plus sign, open its parameter info. Okay, by default there are a number of parameters 4 and numbers of simulation 5. You can increase the numbers of simulation for calibration between 200 to 1000, and for validation in such a ways you can use numbers of simulation between 200 and 500, not 500 actually. You can increase even 2000 simulation. It's possible, but for me I take the default simulation number as well as the default parameter number, because it may take if I increase the numbers of parameters and the numbers of simulation, it will take time. Therefore I will leave this as a default numbers. Therefore simulation number I will leave it as 5, but you can increase the numbers of parameters by clicking here. There are so many parameters to enter. This is Bayesian parameters. These are the Bayesian parameters. Soil parameters. Here soil parameters. These are the soil parameters. Hydrologic response unit parameters. There are a numbers of these are a numbers of parameters. Therefore you can increase by clicking here and search a parameter type and a parameter name. Here also the working minimum and maximum values can be taken from this absolute SWAT values by clicking. For example, groundwater revamp. There is a description, full description here. It ranges from 0.02 to 0.2 here. Groundwater. Okay. Let's take groundwater QMN. Groundwater QMN, for example, it ranges from 0 to 5,000. Therefore, here, okay, I will leave it 5,000. You can edit in such a way, but these are the default numbers. For example, groundwater delay. For example, the other one, carbon number 2. The default value is negative 0.2 to 0.2, and I will, but here in this absolute SWAT values, the working range for carbon number is between 35 to 98. Here 98. You can edit methods of parameters as relative, replace, and absolute in such a ways. Here relative, absolute, and replace you can select based on your decision. Then you can enter in such a ways. Here I will go to SUFI to SWAT editor. This is 5 index simulation number and starting simulation number. You have to edit these two. Mostly you have to take care index simulation number must be the same as numbers of simulation. You have to, this is 5 and this is 5. Therefore I will leave in such a way. The next one is observation section. This is observation section. Their text files are available here. Observed text, observed HRU text, observed sub-Bayesian text. I have to edit this one. Click plus sign. This is all are inactive. Therefore, to make active, I have to select this one and here click reach. Now observed reach becomes active. Therefore, click it to open it. Therefore, numbers of observed variable for me 1. Flow out. No, this is sub-Bayesian number. Therefore, my sub-Bayesian number actually 27, in which this is the number in which your outlet lies. For me, my outlet lies in the sub-Bayesian number 27, and actually I have 27 sub-Bayesians in my watershed. Therefore, I have to edit this one. Therefore, before that, I have to open flow data, observe flow data. you need to prepare in such a ways in 3 column, but if you just perform with flow separation, you need to add another 4th column. Basically there are 2 types of here, but mostly there is for me I didn't perform this flow separation. Delete this one and replace with the new value first. I'll go to edit. I have to make sure this one is 2216 data points. This is 216. Therefore observation is okay. I have edited in such a way. The next one is extraction. I have to edit extraction section. There are 2 types of files, .text and .def text types. Therefore I have to edit this click plus sign, then open it. These are the sub-basin outflows. Therefore I have to delete this and type this sub-basin number in which your outlet lies. Open extract reach. Numbers of variables to get. If you have segment data and you want to calibrate segment data, leave it as a default too, but you have to choose one as a numbers of variables to get, because I need to calibrate stream flow only. Therefore I have to edit this 18 because 18 is segment data. Therefore total numbers of reaches of subbasin I have totally 27. Numbers of reaches of subbasins to get for the first variable I have to delete one. I want one reach only. Here 27. These are subbasin numbers. 7 is a subbasin number, default subbasin number. I didn't have second variable, therefore I have to delete these 2 rows. And I have to edit beginning years of simulation not including warm-up period as 88 and ending years of simulation as 2005. But you can check this warm-up period in this file show. Beginning years of simulation is 1980 and here numbers of warm-up periods have been taken as 8 years. Therefore I have to edit in such a ways. I will start by 1988 2005. Okay, now everything is right. Therefore time step you can use 1 for daily and 2 for monthly. I will leave it the default because my simulation is on a monthly basis. SWAT simulation is on monthly basis, therefore 2 is also okay for me. The next one is objective function. I open it by clicking plus sign, observed reach, observed text file. Numbers of observed variables for me there is only one observed file, that is stream flow alone. Objective function type R square is better. I will leave minimum values of objective function threshold for behavioral solution as 0.5. This I have to edit this as 27. Here, if you have dynamic flow separation, you need to include the 4th column in this outflow section. Delete it, paste it. There are 216 parameter data points. Data points. There is percentage error here. You can use your own as 8 or 12 or 15. You can such like, but according to researchers, it's better to use 10. Therefore, you let the default value as it is. But I didn't perform these 2 dynamic flow separation and constant flow separation. Therefore, I didn't have to include this flow here as a 4th column. Open this var file name delete it. Here's replace 1 with 27. Now everything is right. Save all here. I will go to no observation. For no observation, yeah, copy here. These two are no longer there, and the default one. Therefore, I didn't want to extract subbasin. Therefore, select all and delete. No needed. Paste. No needed. HRU as well. Select all, delete, and substitute with no needed. Paste it. So these are no needed. These are not needed. Only I want to edit is this one. Extract reach number observation. Okay. Numbers of variables to get without no observation. The 3, the default one. I have to use it. That means discharge. That means R flow, R evap, and R segment out. Therefore, I have to leave this one as it is, and I have to edit this one. So number of subbasin is 27. Numbers of subbasin to get for the first variable, it is 1. 1 subbasin only. Here 27. Here as well, I will do the same. 1, 27. Here 1, 27. I have to adjust this one. 1988 must be the same. The above. Now everything is okay. Save all. Then the next step is just to calibrate the model by clicking this calibrate. There are executables as 3 files here, and you have to run all 3 by clicking calibration button. Therefore, execute all. Click this one. Yeah, type yes. Okay, process is finished. Close window. Okay. Start execution of SUFI to run. Okay. Yeah, as you can see, SWAT-Cup is running, and these are parameters. Carbon number 2 parameters are modified in 178 HRUs. As you can see, these are HRUs. Yeah, this is simulation. Simulation 1. These are parameters set for simulation 2. Adjusting the new parameter. This is replacing with the new parameters. This is simulation number 2. By the way, these no observations are just designed for extraction and visualization. Therefore, their main purpose is for visualization only. How our model performed, that is visualizations of uncertainty. Therefore, for visualizing uncertainty, you can edit this section, then finally run calibration. As you have seen. On the next video, I will show you how to validate Arc SWAT model. Please don't forget to subscribe, share, like my videos. Thank you very much. This is simulation number 4. Actually, can't delete this one, please, because it's for visualization and for this tutorial. Okay, process is finished and close the window. Okay, start execution of SUFI post bat. Okay, it completes R square. Okay, yes, I want to iterate. Yeah, iteration 1 with 4 parameters. Okay, yeah, here iteration history. There is folder. I have to open it. I can visualize all this calibration outputs. I can see prediction uncertainty here. Mostly SWAT determines, as you can see, estimation by SWAT is larger than the observed one. This customary. This is 95% prediction uncertainty plot. Therefore, yeah, this is dot plot. As you can see, the numbers of dots for cut number 2 parameter is 5. Therefore, we can understand the numbers of dots equals to the numbers of simulation. As you can see, yeah, this is dot plots for parameters. Best parameters here, best fitted, minimum and maximum value. You can take this. If your calibration in R square value is right, you can take these values. Then finally summary stats. As you can see, R square 0.69, it's okay, but you need to R square should be close to 1. Ashcliffe's coefficient here 0.23, it is not enough. Percent bias 84 is not enough as well. You need to consecutively run your model for that R square and Ashcliffe's coefficient, percent bias, and extra coefficients should be optimized to a true range, working range. Therefore, you need to consecutively calibrate your model. Therefore, for example, percent bias should be within a range of -25 to +25. Therefore, I have to calibrate to get the best percent bias range. This is all today for today. Thank you very much. On the next video, I will show you how to validate Arc SWAT model. Don't forget to subscribe. Thank you very much.